So that's how our application is performing right now. Let's think about how we might want to try and tune this application. So remember that garbage collections that take place in the young generation are better for performance than garbage collections on the old generation. Young generation garbage collections are quick and efficient. We won't notice any real impact on our application's performance, certainly compared to a old generation garbage collection. Now, in this instance, we know what our application is doing. And actually, this is a key point. We need to think about what the behavior of our objects are. In our application, lots of objects are going to live for a short while, and then will find themselves without references on the stack anymore, or rather they're eligible for garbage collection. This is this special scenario I wanted to set up, and because it doesn't match the default Java assumption. We talked about that before, you might remember. It's that most objects live for a very short time only, and those objects that are going to survive a few garbage collections are likely to live for a very long time. What we have here actually is the opposite of that, because our objects are surviving a number of garbage collections, but then they are going to be free and available for garbage. So our objects are surviving for a short while, rather than most objects not surviving any time at all. Now this, as I said, is not necessarily the most realistic scenario, but it means that when we start tuning the garbage collection for how the objects in our application behave, we should see some real impacts. So one thing we'll certainly want to do is minimize the number of full garbage collections. One way of trying to achieve that is by using 3 different runtime tuning flags. Firstly, we can resize the different parts of the heap. We could say we want to allocate more of our overall memory to the young generation and less of our memory to the old generation. Doing that will mean that the garbage collections on the young generation will happen less frequently, meaning that more of our objects will be garbage collected earlier, so fewer of them will make it through to the old generation. And we can also alter the thresholds for how many generations of garbage collection an object needs to survive before it gets moved to the old generation. So let's have a look at the different arguments for these parameters, and we can check what their defaults are. So the first parameter that we're going to look at is called new ratio. The meaning of this flag is how many times bigger should the old generation be compared to the young generation. So if this flag was set to, for example, the value 4, it would mean the old generation would be 4 times bigger than the young generation. If we had a heap of, say, 10 megabytes, we'd expect the old generation to be 8 megabytes and the young generation 2 megabytes. Let's find out the default value of this flag using jinfo. So I'm just going to get my console window back. I'll recall the previous command, but the flag we're interested in now is new ratio. And we're told that the default value is 2. So the old generation will by default in this example be twice as big as the young generation. Now we want to increase the size of the young generation and reduce the size of the old generation. So we want this new ratio figure to be smaller than it is right now. Well, it can't actually go below 1, and it does have to be a whole number. So the only real option available to me right now is to set new ratio to 1. And then if we do that, this should split the heap equally between the young and old generations. So let's just do that, and we'll then look at the heap again with JVisualVM to see the impact. Before I stop and restart the application, we'll just remind ourselves that the old generation is currently 13.5 megabytes and the young generation is 5.5 plus another 4, that's 9.5. They have been resized actually by the JVM while this was running, but let's try and remember those figures, and then we'll stop our application running and we'll restart it with this flag. So I'm going to click on run configurations, and we'll add in another flag now, which is -xx : new ratio, and we're going to set that equal to 1 this time. We'll click on run, go back into JVisualVM. We'll need to reconnect because the process ID will have changed. We'll go straight into Visual GC, and yes, this time the old generation is 10 megabytes. That's half of our total 20 megabytes, so that looks good. That flag has worked.